Hey everybody, Mr. Covey here, and today we're going to be talking about the surface area of regular pyramids. So first off, definition. So a pyramid is a polyhedron in which the base is a polygon. So our bottom base is going to be a polygon. This shape there is our base. We are going to be looking at regular pyramids. So whatever our base is going to be a regular polygon. So an equilateral triangle, a square, a regular pentagon. It's going to be some regular shape. So that is our base. There are two different types of heights that we talk about when discussing a pyramid. So the first is what we just call the height, the altitude or the height. And that is kind of hard to see in this picture, but I have another picture that I think makes it clearer. So if you look at this picture, that distance there is what we call the altitude or the height, the normal height. The way I think about it is if you were going to take an elevator from the bottom of the pyramid to the very top, that distance is the height. Now, you'll notice here we have a different distance that we call the slant height. And that is if you were to climb up the side of the pyramid to the top. So that's kind of how I think about that. That is called slant height. It is different than height or altitude. Okay, so our slant height here is up to the top from there. It is perpendicular to the side of our base there. And we call the top the vertex of our pyramid. The lateral faces are those triangles that have a common vertex in this case. And they're always going to be congruent, all of your lateral faces. And our base, again, is the regular polygon on the bottom. Okay, so I think we have all those vocab words down. Note that the base of a pyramid, again, it can be any polygon. In our case, it can be any regular polygon. So here is one pyramid with a hexagon base, regular hexagon base. Here's a pyramid with a regular pentagon base. It doesn't have to be a triangle. And then let me flip through a few more. There's a famous pyramid that you see. And I want to talk about our formulas and kind of where they come from. So if you think about unfolding a pyramid, let me put this somewhere. So if you think about unfolding a pyramid, it kind of ends up looking like this shape here. If we look at the sides that make up the surface area, we have, let's talk lateral surface area first. So we want to find the area of these four triangles. They have a base S, and the height is the slant height. We call our slant height L. Okay, so to find the area of each triangle, it's 1/2 base times height. In this case, our side length is our base, and our slant height is the height of those triangles. There's 4 of them. And so you could write it like this if we rearranged it. And if you look at 4S, that is just the perimeter of our base. Okay? So we could also think about this as the perimeter of our base times 1/2 our slant height. And that's the formula that we're going to use for our lateral area. Okay? So if we slide down here, excuse me, these boxes out of here. If you slide down here, since each triangle has an area of 1/2 LS, all 4 of them are going to have an area of 1/2 PL. So this is how we're going to find our lateral area for our pyramids. And then to find our surface area, we just need to add the base. And in this case, we're only going to have one base because we have that vertex there at the top. So in this case, the base would be the square. In that first picture we looked at, it would be the triangle. Whatever shape it is, you need to add on that base there to the lateral area. Okay, let's look at a few examples here. Okay. So here's our formula we're going to use. Let's look at this first one here. So we want to find the surface area of this pyramid. Let's find the lateral area first, and then the surface area. Okay. So our lateral area is going to be 1/2 PL. Look at our base. It's a pentagon. It's a regular pyramid, so it's a regular pentagon. So the perimeter is 4 times 5, since each side's 4. And now we just need to find our slant height L, which is this 6 that they give us here. So again, that's the slant height because it's not straight up and down, it's kind of slanted up the side. So throw that in, and we can solve for our lateral area. 60 units squared again, because this is an area. Okay, so now if we want to find our total surface area, we need our lateral area plus our base. Our base in this case is that pentagon. So now this ties back right into what we did last chapter. We got to find the area of a regular pentagon. We know a side length, so we're going to use 1/2 AP. We don't know A yet, so I'll leave that blank. We know our perimeter is 20. Let's go about finding our apothem on our base here. Okay, so you got a few different ways you can do this. That's going to be 2. Let's do the way where we do 360 divided by 10, 2 times 5, to get 36, and that will tell us this angle here. So that angle is going to be 36 degrees. We know that side's 2, and we want to find our apothem here. So I'm going to set up a tangent problem. Make sure we have enough room here. So tangent of 36 equals 2 over A. Solve for A. We should get right around 2.7. An important thing, please keep that decimal in your calculator. Don't round it early. So you need to keep that right in your calculator and then go back over to your calculation you're making over here and do 1/2. I'm just going to write 2.7, but you should keep that whole decimal in your calculator and not round until the end. Okay, so back over here. Here's the area of our base. We're going to add that to our lateral area that we found, put it all together, and we should get that our surface area is 87.5 units squared. Okay. I want to slide down and do one more example. We want to find our lateral area and then our total surface area. The lateral area is going to be 1/2 perimeter of the base times the slant height. Our base is a square, so the perimeter is going to be 4 times 4, so 16. And our slant height is 7. So then our lateral area is going to be 56 units squared. To find our total surface area, we just need to take our lateral area and add whatever our base is. In this case, our base is that square at the bottom. So it's just going to be 56 plus the area of that square. So 4 by 4 square, so its area will be 16. And the total surface area will be 72 units squared. Okay, so we'll do some more practice in class, but that concludes 12.2.